Okay, so today we're going to start with lesson 8-2, scientific notation. I just need to check to make sure I'm not writing off the board. There we go. Okay, so scientific notation. To have a number in scientific notation, it is written as a product of two factors in the form A times x 10 to the x, or n, they have it in n here, we'll put an n, where A is an integer and it has to be greater than or equal to 1 but less than 10. So we'll write it 1 is less than or equal to A, which is less than 10. So the integer has to be greater than or equal to 1 but less than 10. And n is our exponent. Tells us what power of 10 we are going to be using in scientific notation. Okay, so all of scientific notation follows this pattern. Okay, so let's start with just recognizing whether or not a number is in scientific notation. So let's look at the number 3.42. 3.42 times 10, and that is going to be to the -7. Okay, so the first thing you want to look at is, do you have the two factors? Yes, we do. Now, is this factor between 1 or equal to 1 and less than 10? And yes, it is. Okay, so yes, this fits, and this is a power of 10, 10 to the -7. So this is, yes, it is in scientific notation. And we'll just be using SN for scientific notation because I am lazy. Okay, so let's look at our next one, which is going to be 52 times 10 to the 4th. Okay, so first of all, do we have two factors? Is this a product of two factors? Yes. 1, 2, we have two factors. Is 52 a number that is greater than or equal to 1 and less than 10? No. In no one's world is that a number that is greater than or equal to 1 but less than 10. So this is a no. This is not in scientific notation. Now, at this point, we can talk about adjusting. We're going to jump around just a little bit, but making sure that we do know how to put a number into scientific notation from here. So let's say that we know that our decimal point is here at the end of our number. And that should be something that we all know, that at the end of every number there's a decimal point. Even though you don't see it, you know it's there. Okay, so I've just added it so that I know it's there. So I know that I'm going to move this decimal point over one place, okay, which means that what I'm doing is I'm basically adding another exponent here. So this will become 5.2 times 10 to the power of 5. Okay, more on that later, kind of jumping the gun, but just thought it was out there and it was in front of us, so we might as well look at that. Okay, so let's just talk about, putting a number into scientific notation. Okay, let's go ahead and change the page. I know that's probably a very exciting thing for you to watch me do. Okay, so let's take a wicked big number. Let's take 32 trillion, quadrillion, bunch of zeros. Let's do 3 more just because they're fun to write. And let's say, okay, now don't forget, where is our decimal point? Oh yeah, that's right, Mrs. Basic, it's at the end of our number, right here. Okay, so we need a number, looking at this, a number that is greater than or equal to 1 but less than 10. Once again, I'll say that an awful lot. We know that we're going to have to put that decimal point right here, okay, between the 3 and the 2, because that gives us 3.2. So there's our first product. We're going to multiply that times a power of 10, okay? Now we've got to figure out what that power of 10 is going to be. So what you want to know is, how far does that decimal point move? Well, in this case, it moves 3, 6, 9, 12, 13. So this is going to be to the power of 13. So in scientific notation, this becomes 3.2 times 10 to the 13 power. Now we can also look at small numbers, very, very tiny numbers. So let's look at 0.000000147. Okay, so we start out again. In this case, we can actually see where that decimal point is, and understanding that we need to have a number that is greater than or equal to 1, but less than 10, we know that that decimal point is going to have to move to that location between the 1 and the 4, which will give us 1.47 times 10. And now we're moving to the right. So we're moving and we're looking at very small numbers. And remember, in our last class, we had been talking about negative exponents. And those negative exponents, for the most part, we were dealing with them and putting them into that fraction form, and they were coming from numerators becoming denominators, making them fractions. So now what we're saying is these are decimals. Decimals are just a different way of saying a fraction. And so what we're going to do is when we move this, we're going to move it 1, 2, 3, 4, 5, 6, 7 places, but we're going in the negative direction. We're going to the smaller side, so we are at -7. So when we move our decimal point, so when we move to the right, okay, so moving into the right direction, this is where we go into our negatives, okay, and when we move to the left, this is when we are looking at our positives. If you would just always keep your number line in your head, realizing that when we have a number line and we are looking at 0 in the middle, well, actually it's reverse of that. So these are actually our positives and our negatives are down here. So it's kind of going in the opposite direction of what we actually expected to do. Okay, so just keep that in mind. Okay, so now let's look at taking it out of our scientific notation. Let's flip the page again. Okay, so let's take a number 8.9 times 10 to the 4th power. Okay, so literally I'm taking my 8.9. I'm going to add some zeros because this is a positive exponent. I know that I am going to have a big number, and I'm going to move my decimal point 4 places. So 1, 2, 3, 4. I'm going to rewrite this number so that it's easy to see, and it's going to be 89,000. Okay? And the reverse is going to be true for our negative exponents. So let's say we've got 2.78 times 10 to the -5. Okay, we will write down our 2.78, but then understanding that the -5 tells us it's going to be a very small number, we're going to add our zeros on the left, and we will be moving it 1, 2, 3, 4, 5 places, and rewriting that number is going to be 0. We've got 4 zeros, 2, 3, 4, and 2, 7, 8. Okay, so bringing it in and out, not too difficult. We're going to talk now about using scientific notation. When we use scientific notation to order numbers, so here we're going to be ordering numbers. Order numbers. Okay, let's say we've got a list of numbers, 60.2 times 10 to the negative fifth power. We've got 63 times 10 to the fourth. We've got 0.067 times 10 cubed. And finally, 61, we'll put it right here, 61 times 10 to the negative 2 power. Okay, so the first thing that we should always follow the rule of thumb that we are going to always put our numbers in scientific notation first before we compare. So our number is 60.2 times 10 to the negative 5. I have to move this decimal point one place left, which is in the positive direction. So this is going to be, I'm moving it one left, so that's plus 1. So I'm going to add this on here, and that's going to be 6.02 times 10, and now I'm at the negative 4. My next number is 63 times 10 to the fourth. I have to move that decimal point also one left, adding 1 here. So that becomes 6.3 times 10 to the fifth. My next one, 0.067 times 10 cubed. Here I have to move my decimal point 2 places right. Right means we are subtracting 2, so this becomes 6.7 times 10 to the first power. And finally, 61 times 10 to the negative 2. We have to move this one left, so this is going to be plus 1, and now we have 6.1 times 10 to the negative 1. Well, actually, when you get them into scientific notation, it's actually very clear what the order is. They are asking us to put it in least to greatest. Our smallest number is going to have the smallest exponent here. So this is my least. This is my greatest. So if I'm numbering them, so my number 1 for least, then I'm going to come down to my next negative. Oh, you can't even see that. Ah, it's really pretty funny. Okay, so this one goes second. Yeah, isn't that funny how I hide things from you? And then we're going to go here to the third, and then here, this is the fourth. This is the greatest number, so it's fourth in the list. Okay, so I think you can see all of that now. Yeah, I like to keep things secret. The last thing that we are going to look at is multiplying in scientific notation. Basically, this is really kind of one of the most important things that we are doing. They don't have dividing on this, so we're not going to talk about it, but multiplying in scientific notation, we will be doing a lot, and we'll be looking at this a lot. So let's say we've got 2.5 times 6 times 10 cubed. 6 times 10 cubed. Okay. What we're actually doing here is not multiplying anything times our power of 10. We are just multiplying the 6 times the 2.5. 2.5 times our 6 gives us this 30. This 12 is 15. And we have one decimal place here. So what this gives us is 15 times 10 cubed. Now, hopefully, you're looking at that going, wait, Mrs. Basic, no, that's not scientific notation. I hear you. I know you're saying that. So what we're going to do is we're going to take that decimal point that we can't see. We're going to move it left. We're going to put it in the right place. We're going to add 1 here because we moved it left. So we've got 1.5 times 10 to the power of 4. Okay, let's do another one because that was so fun. Okay, we've got 0.4 times 2 times 10 to the negative 9 power. And, okay, so, well, we'll do it out because, you know, I just kind of feel like making sure it's correct. 2 times 4 is 8. What? Yes, and I've got 1 decimal point. Okay, so this comes out to 0.8 times 10 to the negative 9. Notice this just comes right down here. And then I say, again, no, Mrs. Basic. You'd be raising your hand right now going, wait, that's not in proper scientific notation. And I'd be saying, oh yeah, it's not. Okay, so now we've got to move it here to the right one. Okay, because we're doing that, we are subtracting 1. Okay, because we moved it to the right. And so this gives us 8 times 10 to the negative 10 power. Okay, and that is our scientific notation lesson. Please feel free to watch it 2 or 3 times for the utter enjoyment of listening to my voice. Okay, that's it. I am shutting down.